Hello everyone, this is Harry Gill, and in this video we are discussing introduction of threads. This is the part 1 of concurrency chapter of the book. If you have directly landed here, this video is a part of series that I'm preparing for Java certification. I will add a card in this video and also a link in the description of the full playlist. I have skipped over to concurrency upon request. Once done with this, I will continue with the regular sequence of the book. If you want me to cover any other chapter after this, let me know. I will first cover that and then continue with the regular sequence. We will look into two different topics. First, we will see the theoretical part of threads and explain what threads are. And then we'll look into the program and see how to create threads. So let's first look into the terminology. A thread is the smallest unit of execution that can be scheduled by operating system. A process is a group of one or more threads that are run in a shared environment. And by shared environment, it simply means that multiple threads run in the same memory space and talk to each other directly. If they're not in the shared environment, then the two threads cannot talk, like they don't even know that the other thread exists. We will also see in our future tutorials like how to communicate in between two threads if they are in the shared environment. Single-threaded process is a process that have exactly one thread, and multi-threaded process is a process that has more than one thread. To show it in a diagram, so let's say we have a process, and let's say it's a Java program, and then any process that is run by the operating system will have a memory associated with it where it stores all the stuff that it needs to run the program. And it's not specific to Java program. Any process that runs on the operating system will have a memory. Now let's say this program has multiple threads in it. So all the threads will be using this memory that is reserved for the process. And when the threads has to do some computation, it needs a CPU. And to get the CPU, it takes the help of OS thread scheduler. So thread scheduler is something that is built in the operating system. The purpose of OS thread scheduler is to find a CPU that is available for a given thread. In Java, there are two types of threads. There is a system thread and a user-defined thread. System threads are the threads that we do not interact directly with. For example, when we run a Java program, any Java program, there are some background threads running. For example, the garbage collector that cleans up the memory periodically. And as a programmer, we don't directly deal with the garbage collector. So JVM takes care of it, and it's always running in the backend. So garbage collector is a system thread. User-defined threads are the threads that we will create in our program, and we will see how to do that in the further slides. Note that every Java program that we have run is in fact a multi-threaded program. It's just that we haven't dealt with the system threads directly, and JVM is creating other threads, and the program that we have written in the main method is just one of the thread that JVM controls. In the previous slide, we have seen there is a OS thread scheduler sitting in between thread and CPUs. So that scheduler uses an algorithm to decide which threads get the CPU time. One of the most commonly known algorithm is round robin scheduling, in which a fixed amount of time is given to each thread. And as soon as that time amount is over, the thread is taken out of the CPU and the next thread is put in for the computation. And OS goes in a round robin fashion, starting with thread 1 to the last thread and then coming back again to thread 1 and so on. Another commonly known algorithm that OS scheduler uses is priority based scheduling. So in this case, OS scheduler will always pick a thread which is of higher priority. So priority is something which is associated with the thread. In Java, priority is is represented as an integer number, and if scheduler sees a higher priority thread coming in, it moves out the lower priority thread out of the CPU and gives the CPU to the higher priority thread. The process where the operating system takes out a thread from the CPU and puts a new thread in is known as context switching. Now let's see what is the process of creating a thread. Creating a thread is a two-step process. In the first step, we define a task that a thread will do. And in the second step, we start the thread using thread.start. And then the thread will start doing the work that we just defined. Now, defining a task can again be done in two ways. We can create a class which would implement a runnable interface and then override the run method, and then we can write the code within that run method. Or we can have a class that extends thread and then override run method. We will see both of them in practice. So let's jump over onto IDE. First, we will write a program to create a thread using the runnable interface. So we'll create a class that will implement runnable. So I'll start up IntelliJ, create a new project, and I will name the project as Concurrency. For the first way, I am going to create a package called part1.runnable. In this package, I'll create a class called printNumber. And this class will implement the runnable interface. So this is the first method. We have looked into how to define a task. So once I have that, IntelliJ will give me an error and ask me to override the run method. So in this method, let's print a number from 1 to 10. I'm creating a for loop which will print the numbers from 1 to 10. And note that I'm using some of the IntelliJ provided shortcuts. Like in this case, I have used sout, which is short of system.out.println. So if this shortcut is not available in your IDE, or if you are typing the whole code, so just spell it out manually. We have defined the thread functionality where we will be printing a number from 1 to 10. Now, as a next step, let's create a main class which will have a main method, and that main method will create a thread and start the thread which will print the numbers. And I'm using the main shortcut again here for the main method. So I have created an instance of thread by saying new thread. In the constructor of the thread, I need to give the instance of the class which I have implemented the runnable interface. So this is how I'm associating the task that I created with the thread. And note that I'm not starting the thread yet. I'm just creating or defining what the thread will do. And now we'll do the step 2 of the process, which is starting the thread. When this statement is executed, that's when the other thread gets started. So in the previous one, we just defined it. We didn't start it. So it's very important to note that. Let's also add a couple of print statements. I'll add a print statement before defining the task, and then once after we have started the thread. And I'll save the program, right click, run. And in the output, as you see, we have printed start of main thread and end of main thread, and then the 10 numbers. So in this case, before even the thread which prints the number got created and executed, our main thread even finished. There is some time spent when the new thread is created. So in this case, the time is so big that the main thread even moved forward and printed end of thread before the print number thread even started getting executed. So let's jump back to the slide, and I'll show you exactly what process is happening in this program. So when the code is run, we have a main thread and it starts executing. As soon as it hits thread.start, it creates a new thread. And once that new thread is created, the main thread will continue and the print thread will continue as well in parallel. The stuff that happened before was we added a print statement. We also defined the task, what the task will be done. And in the main method after start, we had a print statement which prints end of main thread. And the task of actually printing the numbers from 1 to 10 happened in the print number thread. So that didn't happen in the main. Now let's jump back into the IntelliJ and see the second way of creating or defining a thread and running the program. So I will create a new package called part1.extending thread. In this package, I will create a Java class. Again, I will name it as print number. And in this case, instead of implementing runnable, I will extend thread and I will override the run method. And in that method, I will again print the numbers. Next, I'm going to create a main class. In the main method, I will create the instance of print number. So now this is the main difference on how we have created a thread. Previously, we created the instance of a thread, and in the constructor, we gave the class instance which implemented thread. But in this case, we are creating the instance of the thread itself. And then starting of the thread is still same. So we will just do thread.start. And like in the before program, let me add print statement before and after. And now I will run the program. So as you see, the output is very similar. So the main thread prints start of main thread and end of main thread. And then we print the numbers which are in a different thread. In this case, I only print up to 9. So, but that's just the way I have written the program. So that's pretty much it for the second way how we create a program by extending a thread. Now for the exam, it's a very important thing to note that make sure when you see a thread related code and when a thread is started, it's started using thread.start. To trick you, the code might have thread.run. So this program will work fine. There will be no compilation error. But however, the main thing is, so we are not creating a new thread in this case. We are only calling a run method, which we have overridden in print number. And if I run the program, you see first we printed the statement start of the main thread, then we printed all the numbers. And then at the end, we printed the end of main thread. So essentially, the whole program is going sequentially and there is no thread created. So just be mindful how the thread is started. And this particular program is perfectly valid if you are writing a single threaded program. So in exam, make sure you make a note on how the thread is started. As you have seen, there are two ways to define a task that a thread will do. One way is to create a class that implements runnable, and the other way is to create a class and that extends thread. And in both the ways, we write our code in the run method. Now you might be wondering which way is better than the other. And the answer is, if we have to choose in between these two ways, we should always choose the way where the class is implementing the runnable interface. To see why, let's jump onto the IntelliJ. Java does not allow us to extend more than one classes. So if we have already extended a class from thread, we cannot extend that class from any other class. Say in this example, if I want to inherit this print number class from the print number class that is in part1.runnable package, I will get a compilation error and it says cannot extend multiple classes. So this is one reason we lose the capability of extending our class from something else if we extend it by thread. The second reason has more to do with the inheritance concept itself. Inheritance is used in the instances where we would want to create a specific behavior of a class. In this case, we are not creating a specific behavior of thread. We are not changing the way thread behaves, but we are only printing some numbers. So it doesn't make sense to extend a class from thread to do our job. These are the two main reasons why we should define a task of a thread by a class that implements Runnable Interface. Before I end the video, I would like to go through one last topic, which has to do with the functional interfaces. So the code that we have written to create a thread by implementing the Runnable Interface, we can write the exact same code using the functional interfaces. And that way, the number of lines we write is a lot less and the code is more readable. Functional interfaces and the lambdas are a different concept. We will go through into the different videos, but for this video, note that a functional interface is an interface which has only one method, and the runnable in Java is defined as a functional interface that has a run method which doesn't take any inputs and doesn't return any outputs back. I will take the code that is run in the print number class and go to main class and implement runnable in the main class. And now because I have implemented, I also need to override the run method here. And instead of giving the instance of print number as an argument to the thread, I will give the instance of main, since we have moved the code. Now we don't need print number class, so I will delete it. And now I will run the program just to make sure that it's working fine. And I'm seeing the same output as expected. Now I'll convert this code and use the functional interface. And the code that I have written in the run method, I'll move it to this functional interface. And instead of giving the instance of the main, I will just give the task variable, which is the functional interface. And now we don't need the run method, and also we do not need main to implement runnable, so I'll delete that piece. Now we have converted our program using the functional interface, and if you run the program, it will work fine. Before I run the program, let me reduce the number of lines further. Note that now I'm not changing any fundamental behavior of the program. I'm just refactoring the code to reduce the number of lines. So for that, instead of creating a variable and then passing it into the method, I will create the functional interface inline. And now we don't need the task variable. Also, as you note, we have done two steps in the two different statements. So first we have defined what the thread will do, defining a task, and then we have started it. We can start the thread in the same line, and now we don't need to have another line here. And since start doesn't return anything, I will simply not assign it to any variable. So in here, note that we are still doing two steps. It's just that we are writing the code in one line. So we are still defining a task and then starting it. We are just reducing the number of lines. And this code is exactly same as the previous one. And now I'm going to run it, and you will see the output is exactly same. This concludes the video. If you liked the video, please hit the like button and subscribe for my upcoming new videos. I will see you in the next one.